Okay, guys. So let's review exponent laws. When the bases are the same, so we're talking about, oops, we have reviewed this so much, you're right. So when the bases are the same, be multiplied, we add the exponents. Oh, we're not doing trig. Okay, when we're being divided the same bases, what do we do with our powers? Subtract a power to a power. We multiply. This is the power of product rule. So what would this become? AMBM. Then we have our quotient of power rule, I think it's called. Power of quotient rule. Comes AM over BM. Anything to the power of 0, 1. Negative exponent, what does it do? 1, go to the bottom, 1 over a to the power of r. If you had a fraction to the power of a negative exponent, what would we do? Flip it. Flip it good. And fractional exponents are related to roots. Power. A fractional exponent?
Yeah, how would you, like, you know, like a squared is a times a. How would you, like, write out fractional exponents?
Like
a to the 3 over 2.
Like 1 over 3? So it's power over root. So we turn, oh, you mean like write it out as, you just turn, it's related to a radical. So that's what it is, right? So it's power over root. So this would be the nth root of a to the m. Yeah. Or the nth root of a all to the power of m. Okay? So yeah, this would become the cubic root of a. So we're comfortable with these, right? Because this is a review stuff. So let's talk about logs. Oh, I should have brought my log jokes. Oh well. Okay. I do have a log joke. I have to remember it though. I do have it. Have you ever heard the dirty tree joke? Oh, you want to hear it? Okay. So a foreman was doing an interview for a guy applying for the job. Let's call him Joe. So Joe comes in and he's going for this interview. And right away, the foreman's like, I'm going to stump this guy because I don't want to hire him. Did not like, he's a newfie, let's say. Okay? He's a newfie. And that's kind of rude. I feel bad saying that. Okay, so he says, I want you to represent the number 9 without using any numbers. Just on paper, represent the number 9. Okay? He's like, this guy is not smart enough to even represent the number 9. That's his thought. So he draws. Oh, you've seen this one? No. Okay, so he says, that's 9. And the guy's like, okay, tell me how that is 9. He's like, tree and tree and tree is 9. Okay, so foreman's like, all right, you think you're so smart? I'd like you to represent 33 without numbers. Like, okay, he thinks about it, and Joe's like really thinking hard. And so Joe finds a brown pen or black, and he scribbles on it. Oh, sorry, it's the number 99. My fault. Number 99. And he's like, there it is. And the foreman's like, okay, how is that 99? And he's like, dirty tree, dirty tree, dirty tree. It's 99. So then the foreman's like, then do 100. How are you going to do 100? Oh, that's a tough one. So he thinks and he thinks and he thinks. And all of a sudden he thinks and he thinks, I got it. There's a dog that came along, and he left a little present by each tree. And he's like, 100. And he's like, how is that 100? Dirty tree and a turd, dirty tree and a turd, dirty tree and a turd. All right, so that's the joke. It's really dumb. Okay. So, can't remember my log joke. I'll think about it. Okay, so a log, it is about a tree, probably. Oh! I have to remember it again. Oh, I'm so close. It has something to do with a log cabin. Okay, so how are the log function and the exponential function related? Inverse. See, you know. Oh, good old AC. Okay, inverse. So, switch x and y, right? Or we could also say it's reflected in the line in y equals x. Okay, so if log, so our base is b, right? Log x base b equals y, then how could you write that as an exponent with exponential notation? B to the y equals x, right? We go b to the y equals x, circle. If and only if. That's what that means. So in mathematical terms, they use this in proofs. It's a real thing. It means if and only if. I don't know. But there's I don't know. Okay? So that's, you see it in proofs all the time in math journals, if and only if. So this is equal to y if and only if this is true. Okay, so express this guy in exponential form. Okay, guys? Write it in exponential form. Go. Go. Done? Okay, so it should be, remember we go from here to here to here. It's like a circle. So our base to this would be our exponent, equals quarter. Yay. Okay, writing this in log form. So log, so again, it's the same idea. So our base is 6, right? Great. Log 6 of h equals t. Yay. Okay? All right. So I'd like you to try the next one on your own. Solve for x. Do you think, or do you need help? You could do it.
Yeah, we can.
So whenever we're solving for x inside a log, we have to switch it to exponential form.
I would say it's 4, 4, 3, 0, 4, 6, 7, 8. That's a really large number. 43,046,700. Yeah. I agree with all of that.
Okay, so whenever you're solving for something inside of a log, we have to take it out of exponential form, right? Or whenever we're solving for an exponent, Adrian, put that away, then we use logs. Thank you. Okay, so what did you do first, Adrian? Two to the 4 log 3x. Good. So 2 to the power 4 equals our inside. So 2 to the 4 is 16. Okay. Again, now what do we want to do? We want to solve for something inside a log. 3 to the 16 equals x. So let's just leave it as 3 to 16 because that's probably a big number. What he said. Okay. So, what's the first one going to be called? What law is this? Which log law? Not the first law, it's a name. Is it the quotient, the product, or the power? Power law. Okay, so here's our power law. What's the second one going to be called? Product law. What's the third? Quotient law. Okay. So what is the product law? What would we do in this case? R log b of x, or log x base b. Okay, so when the power law says that exponent we can bring out in front. The power law.
Are we talking
for log laws?
log laws, not the other kind of power?
No, just logs. These are laws of logs. Just logs.
Sorry.
No, I don't know.
Because it said product law and quotient law?
No steal, just logs. Okay, so this is the power law. The quotient, what is the product law? Tyler, what's product law?
Product law is log b of x plus log b of y.
Thank you. And law, what's the quotient law? Greg, H? Beautiful. Okay, so you need to know these laws. I'm not sure if they're on your 30-1 formula sheet. They're definitely not on your calculus one, right? Maybe we should double check that. Someone has their, it's nice and cool in here now. Are you cold? Oh, it's so nice. Okay, it's refreshing. It feels like it's summer, spring, or like a spring air feeling.
No.
Okay, so looking on your formula sheets, guess what? They're not on there. So you need to know them. I was pretty sure you had to know them, but yeah. So know these guys. You are responsible for knowing them. So literally, guys, we only have to do these 2 questions. And then the rest is homework time. So let's get these 2 done. They're tough. Okay? All right, so use the law of logs to rewrite this guy. Nope, it's not. You need to know them. Okay, so rewrite it so that there's, how can I say this? How do they say it so it's all in terms of logs and there's nothing, right? So each log has only one inside.
Okay.
Yeah. So like, yeah, so rewrite it. You want to try it?
Yeah.
Give it a shot. I'll pause it. Here we go. So the first thing you want to do, guys, is rewrite everything so we have everybody with their own individual power. So bringing the 1/3, that square is just for the d because there's no brackets around it. It would be for both if it was on the outside part. Okay, so that would be c to the 1/3 and d to the 2/3. We can't use the power law until it's by itself, that exponent. So we have to first deal with the quotient. Okay, so that's going to give us log, so 7 AB minus, I'll do it in steps, log 7 C to the 1/3 D to the 2/3. So I dealt with and within that we can use product law here. So log 7A plus log 7 of B minus, guys, now you can put it in brackets. You're subtracting both of them, right? Because this bracket applies to both, or you can just go straight to, so you'll notice everything that was on the denominator will have a negative in front of it. Everything that was on the numerator has a positive in front of it. So you can go straight to that. And so your last step is we want to get rid of these exponents, so we bring them now in front. So log 7 of A plus log 7 of B. Yeah. Minus 1/3 log 7 of C minus log, 2/3. So bring that power down now. 7 of D. Okay? All right, so let's go to the next guy. So what's the first thing we have to do before we can combine our logs? Which law? Power law. Yeah, we have to get what's in front of the logs gone. So where is this 4 going to go? Okay, on top of the x plus log 2 of y to the power of 1/3 minus log 2 to the power of z cubed plus 1 to the power of 2. Okay, now, what law can we use now? So we could do, yeah, the product. Could we do all product and quotient at the same time? Yeah. So we have base 2. So what's on with a plus in front of it is on the numerator. So on the numerator would be what? So we're making a single log this time.
Oh, sorry.
Yeah. So x to the 4, what else is on the top? 1/3. So let's make that as cubic root y. Okay. All over z cubed plus 1 squared. How's that? Not so bad, right? Okay, so that's it for today's lesson, and so your homework is here, okay? So practicing these laws, you get it done, you can go. Happy weekend.
Happy weekend.